Now, if we look at the cellular network, that part of this story, we see that terrestrial wireless communications dates back to at least 1940s. And since the 70s of the last century, we have seen the growth of cellular networks. From the first generation analog communication to second generation digital communication in the 90s, bridging through 2.5G to the third generation, heavily focusing on data application in the last decade, and now to what people call the fourth generation, one of which is called the long-term evolution LTE networks that's being rolled out in America as well as in certain countries in Europe and Asia. Over the next few years, we can anticipate a lot of LTE deployments. Now, back in the 1980s, some estimate that there will never be more than 1 million cellular users in the US by year 2000. It turns out this was one of those way off underestimates of the proliferation and impact of networking technologies. Later in Lecture 18, we will talk about a different kind of wireless networks we also use a lot, the Wi-Fi networks. They started in the late 90s and continues to today. So today's focus is cellular network. And what is a cellular network? Why do we call that cellular? What is a cell? Now, I have to first understand that the air interface of a cellular network or Wi-Fi networks use parts of the electromagnetic spectrum. For example, in Europe, the most popular second generation cellular network was called GSM, and the frequency band around 900 megahertz was devoted to GSM. And one of the popular third generation networks was called UMTS, whatever that means. We're not going to be bothered with the acronyms too much today. 1.95 to 2.15 gigahertz part of the spectrum was devoted to UMTS. And these are the so-called licensed band, meaning that you have to pay government a lot of money in order to have the right to transmit. And for example, in the US, the government has collected tens of billions of dollars from wireless operators and sell them the right to transmit in different regions of the country in different parts of the spectrum. Suppose you are given a certain part of the spectrum, for example, between 1.95 to 2.15 gigahertz. You can divide that further into different chunks of frequency bands.